Hello and welcome to Range of Four's webcast today. Today we're talking about continuous delivery and how to assess your maturity. We're delivering this webcast in conjunction with our partner Pragma. So over to you, Lars.
Thank you, Helen. Yes, welcome to everybody. I want to take you through our model for continuous delivery maturity. See a brief picture of it there. But first, I want to make a very short introduction to Pragma. We are in the continuous delivery business. That's all we do, basically. We're a consultancy bureau located in Denmark. We are 11 employees, and we help companies set up their continuous delivery tool chains and organize their processes. We call ourselves Jenkins CI ambassadors. I don't know if you're familiar with Jenkins CI. It's an automation platform, CI server. I will be returning to that bit a few times through this presentation, but it's an open source tool, and we host a community event every year, and we also develop quite a few plugins for this platform, including some that are directly related to our partners, which among Range of Four, which we're very proud of, also counts IBM and Programming Research, CloudBees, and Atlassian. We're basically service partners to all of these, so we do not sell any licenses, but we help people set up these tool stacks. We're also facilitating a user group called Continuous Delivery Users. When you get these slides, you'll be able to click on that green logo there, and that will take you to the LinkedIn group for that user group, and it's free to join us. So follow whatever is going on there, and you'll be more continuous delivering. We also have a kind of a joint open source roadmap alliance where people can follow different open source strategies together and share thoughts on some of the tools that are used in their tool stacks. Short about me, I'm working with continuous delivery. I call myself a continuous delivery coach. Sometimes I do, at least, but I've been working with configuration management and software quality assurance throughout all my career. So it's the only thing that we're working with, basically. This is the agenda for today. First, I want to take you through the context of continuous delivery, trying to put in what is actually continuous delivery, what is it, what are we trying to achieve. Then I want to take you through the model that we have created, and I hope some of you have also been going through our short survey about how to assess your own continuous delivery maturity. If not, then it's available on CDMI, Continuous Delivery Maturity Index.pragma.com, and you can browse to that page and take the test. But we'll go through the model, and after that, I have a handful of anecdotes and tales from the trenches I can entertain you with, and I intend to do that. So that's it. Starting out with the context. Looking at the phrase continuous delivery, it seems that in the literature and on the articles that we find on the internet and the way that people talk about it, it can mean kind of three different things. The first of them is that it's a natural extension to continuous integration. It's kind of a step two from that part, where you have continuous integration, and then the next thing, then when you have achieved that, you go to continuous delivery. So you shouldn't just integrate, but you should also make it releasable. That part is related to kind of, I think, the Adson Wesley books, Continuous Integration, which you may or may not know, but a year after that book came out, another book came out called Continuous Delivery, and they seem to be kind of volume 1 and 2 of the same set, but it's not quite how we see it. We see continuous integration as merely as a branching strategy for how to share code among your colleagues, and continuous delivery, that is a whole approach to software development. There's also a large group of people who look at continuous delivery as deployment and DevOps features. So it's kind of the natural extent from where software development traditionally ends and the deployment starts and functional testing starts. That's also quite common, that it has a high focus on deployment. What we see continuous delivery as is basically a natural extent of the or support for the agile development approach. Basically, how can you develop something in a 2-week sprint if you don't know what done is? So you need to be absolutely sure that your code is working, and since that is a highly comprehensive task, you want to automate that, and that is what we mean by continuous delivery. I will elaborate on that. But first, I want to take you through a short recap of Agile, the concepts of a backlog, a sprint log, user stories, stand-ups, burn-down charts, team velocity, pigs and chickens. I guess that these are all terms that you are familiar with. Maybe pigs and chickens, this short story. Have you ever seen this one? Hey pig, I was thinking about, should we open a restaurant? The pig says, I don't know, what should we call it? How about hams and eggs? No, thank you. I would be committed and you would be involved. So that sentence, I would be committed and you would be involved, that kind of, divides pigs and chickens. The pigs are committed and the chickens are involved. So we want to get to a situation where we can have kind of a 14-day sprint where pigs are alone and working intensely and focused, and they're not disturbed by their chickens. That is kind of a Scrum approach. It doesn't really work that way if you're working in Kanban, but the principles are the same, that you need to estimate your work, you need to integrate daily, you need to define when something is done, so you need to have your definition of done ready, and you need to have the people who are actually working the plan estimating it. So in this setup, if we're for a second just looking at the Agile manifest, which I guess you're familiar with. Sorry, I didn't want to go there. Sorry. This is where I want to go, to the Agile Manifesto. You're familiar with this, I guess. So there are kind of 4 doctrines, individuals over interactions and so forth, and there are 12 disciplines in here, I guess. What's interesting here is that the first of these disciplines is actually the first time that we see the mention of the phrase continuous delivery. Our highest priority is to satisfy the customer through early and continuous delivery of valuable software. So that is where it all derives from. It's from the Agile Manifest. If you look at principle number 7 down here, this is what we want. We want working software to be the primary measure of progress. So we're done if we got software that is running, and if we haven't got that, then we're not done yet. So this is what we look at. The primary measure of progress is running software. And this is a picture of phases as we see them traditionally in iterative software development. So you have development, followed by integration, followed by testing, followed by deployment, followed by release. This is a typical setup. The problem with this way of working is that if I want to have a release, say in December, I need to calculate my way back through this. I say releases, they usually take like blah, 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 4 days. Deployment, I can do that in a week. Test, well, it's kind of a roundabout. I test something, I fix something, I test something, but it usually takes like 4 weeks. Integration, I can do that in a week. So counting my way back, I would know that I should call frozen zone on the development like 6 weeks before the release date. But what happens if I miscalculated? What happened if some of my estimates were wrong? Will I then do less of the integration than planned, or will I have to release later than I planned, or will I do less testing? So basically, having a phased development process defies not only continuous delivery but the whole agile concept. It's important to understand that agile development is not just iterative and incremental software development cut down into 2 weeks iterations. It's not like that we spent the first 6 days of our sprint to doing something, and then the last 5 days of actually stabilizing it. That's not how it's meant to be. It's meant to work like this, that every time I have something, and I'm supposed to have something daily, I'm going to make sure that this thing that I'm delivering is ready to be delivered at the end of this particular sprint. So it means that for every particular commit I have, I need to do my deployment, integration, testing, and release to be able to see if this is actually working, because otherwise I do not know if it is. So it's a whole different concept. No more phases in your software development process. What do we have instead? Well, instead of phases, you have a pipeline. The idea conceptually is that every single commit is a potential release candidate. You just have to figure out whether or not this particular commit that you're sitting with is indeed or is not a release candidate. And for that, you use a pipeline. You simply have some kind of tollgate criteria, which could be built in unit test. And then if that passes, you will go on to more thorough analysis and metrics. From that point, you can go to deployment, you can go to functional test, you can go through reviews and documentations, and you can go to even more advanced testing. This is just a kind of a template for how it can be done. Pipelines can be quite different depending on which type of company you are. If you're a software game producer, you would have a quite different pipeline than if you were producing embedded software within the manufacturing industry. So it very much depends on what kind of product you have, how your continuous delivery pipeline is looking. But the concept is that it's triggered by one commit, and the commit is then taking a full ride through the entire pipeline. If it passes in the end, you're done. Otherwise, you're not. This is how it may look when you implement it in. This is a picture taken from the implementation of a pipeline in Jenkins. So basically, I have in Jenkins, which is a continuous integration platform, an automation platform, which can do anything I want it to. I can script it to do my own personal customized scripts, or I can use, there are more than 900 plugins today, I think, that can do all sorts of things. I have set this up, and then we have a release that goes, or a pipeline that goes. The first column here is, well, basically the rows here, they're one pipeline. So each row is one pipeline, so started by a particular commit. And the first thing we do is that we build and run our unit tests. The next thing we do is that we run some more metrics, code analysis. The next thing we do is that we generate our documentation, which is embedded in the software. And for the last step, which is in the fourth column with the colors in it, that's actually when we try to do a full functional test that runs for an hour. The picture you see here is just for a small plugin for Jenkins, the one that integrates ClearCase UCM with Jenkins. That's a plugin that we developed for one of our customers, and this is the release pipeline. It's very typical that the last column you see here, which is named release, that's a manual process. So even though if we could potentially release something every time we reach a green box at the fourth column, we're not necessarily doing that because we might not want to release every day. Releasing is a political thing. So this is also an important point, saying that continuous delivery has nothing to do with continuous release. Continuous delivery is relevant even though you have a release policy that says that you want to release like twice every year. Continuous delivery is still the thing you want to use because you want the pipeline, and the delivery is just delivering from one context to another. It could be delivery from the software development team to the manual testers, or for a beta test to a particular customer. So every time the software that you have at hand needs to change hands, that's delivery, even if it may not be a release. This is the full context, starting at the top right corner, where you have a work item, which basically is a post-it note that you take off the whiteboard, and then you start working on it. As a developer, you would make that work on your own computer, and you would shout, "Well, I'm done," and then you would check it into the version control system. The version control system is monitored by your automation platform, which could be Jenkins, it could be Team Foundation Server, it could be Urban Code platform, it could be Buildfork from IBM, or Bamboo from Atlassian. It could be anything really that's capable of doing automation. But that will then pick that information up, and it will kick off the pipeline. And if you're not done, then that message goes directly back to the software developer, who would say, "Well, okay, then I need to fix that, whatever is broken." And if you're done, you would end up having produced a release candidate, something that you, at the end of your current sprint, will be able to present to your product owner and say, "Well, I did this. We managed to overcome this challenge through this sprint." So this is the way that it's working in a continuous delivery setup. It's important to understand that there are no fast tracks or hot fixes in this setup. So these terms are simply erased from our vocabulary. We don't use them. There's only one way to get something out to the customer, and that is to give it a ride through the pipeline. If you cannot get it through the pipeline, then you're not done. And that also means that you have to massage and optimize this pipeline into a level where you're actually content with the time it takes to do a full ride in the pipeline, which may be quite substantial because you have a full acceptance test in there and you have a lot of functional tests. So even though it may be distributed to a lot of different servers or clients, it may take several hours, maybe potentially even days, but there are no fast tracks. The model that we have created here is based on our experiences with helping our customers. When we come to them and are supposed to do an assessment with them, or we're supposed to help them set up their tool stacks or whatever, it's a quite common question that they ask us. They say, "Well, given that we are where we are, what should our next step be from going forward?" And for that, we developed this model that would enable us to have a thorough look at the customer, a 360-degree view that will say, "Where are you? Where do you want to go? And what would other people do in your situation? What is best practice? What is a normal way of going about this?" So this is not a traditional leveled model where you can grow and grow and grow through this, and you have to start in the upper left corner and end in the lower right. You're actually free, as I mentioned previously, to take the elements of this model that are most relevant for you, given the type of business that you're in, and implement them. So this is not an ordered way of looking at continuous delivery. So they are signs of continuous delivery, and we have just ordered them into different levels, novice to expert. We have also ordered it horizontally in 4 different groups: build and test and quality assurance, and software configuration management, and visibility. And these are the main areas that we see in continuous delivery. Some might argue that you would have what about system architecture? What about organization readiness? There are many other disciplines or knowledge areas that you might want to throw into the equation of continuous delivery. And that is true, but we also have to keep this model fairly simple to make it efficient. So what we have tried to do is that we have tried to distribute some of these issues into different boxes in here. But it's obvious that system architecture and organization readiness are candidates to enter into this model at some point. Going through it from left to right, we have verification before commit and nightly builds. That are some of the first signs that we see of some kind of maturity when it comes to build. That people are supposed actually to do some kind of verification on their own computer before they're supposed to share it with their colleagues. And whatever is put into the version control system at the end of the day is built during the night, so that when you come in next morning, you can see what is the current status of the code base. The next thing we see is that people start wondering, well, why is my build server only building during nights? Why doesn't it build all the time? So they basically trigger this to be an event triggered by a commit instead of just, an event triggered by the time of the day. We also see at this point that people start to manage their artifacts, the derived objects from the build process, because that would enable them to optimize their build process, to cut down build times, to reuse some of the derived object as long as they are reusable, instead of having a building over and over again. When people start becoming ambitious about their build setup, what happens is that they tend to look at their Perl scripts and Python scripts and shell scripts and whatever they have and say, how come that we have this kind of hacking attitude towards our build setup when we are making real software that's supposed to be shipped to our customers? We have it modularized, we have it version control, we put in version control systems. So people start looking at their build configurations basically the same way that they look at the rest of their software. It should be managed. The what and the how should be split apart. So what the thing is doing is different from how it's doing it. That enables a lot of reuse. Right? If I want to run static code analysis, that's the same way of doing it. If I want to orchestrate or start a tool, it's the same way of doing it. It's just that I'm starting it differently with different parameters given the context. So I want to split my configurations for the way that I'm doing it. And I also see that dependencies are becoming managed, which means that people start using rather dynamic dependencies in their code base rather than static, so that you even optimize the build better. You introduce artifact management systems such as Nexus or Archiva or Artifactory. Then we see people start utilizing their build setup quite extensively. So they don't just have one master and slave. They might have one master and several slaves, or even many slaves. So they become distributed. Things are doing different things. We're not talking about one server that's running. We're talking about potentially 5, 6, 7, 800s, maybe even for large customers. And we see at this point that we choose to have a truly staged approach to the pipeline, so that a ride through the pipeline is indeed not something that you can bypass through a hotfix or a fast track. In the end, we have seen customers who have had ambitions about actually being able to have their build setup orchestrate their virtual machines, so that I would have virtual machines on demand. If I want a new setup, if I branch out from something and I want a whole new pipeline to be available for my personal setup, maybe not forever, but for a few days while I'm working on this assignment, and that basically spawns off entirely automatically in the virtual machine. So I get virtual machines, I get them started, I get them connected as clients to my automation platform, and I get jobs that are running on my specific branch. And when I close that branch, all these jobs and virtual machines, they go away again. So everything is automated. When it comes to test and quality assurance, some of the first things that we see is that people start doing unit testing. And when they have started with unit test frameworks, they start measuring their code coverage. Those are good measures, and unit test and code coverage should be joined together hand by hand. Making code coverage on anything except your unit test is usually not very interesting. So measuring your code coverage on your functional test, for instance, is not very interesting. And having unit test which are measuring coverage is also pretty lame because you don't have any notion of you're making progress or not. So they are kind of paired together, and they are low-hanging fruits. Most programming languages have unit test frameworks, so it's basically just download it from the internet and start hacking, and you would see improvements tomorrow. The next thing is that people tend to see that as something that's kind of driving a process. I can create metrics about my code. How cool is that? So I can do static code analysis. I can scan my code for fix me's and to do comments. I can measure my cyclomatic complexity. I can count my lines of code. All those kinds of metrics are actually interesting because when I do those kind of metrics, I can visualize what's happening in my code. So even though if they do not necessarily produce a better test, because they're not, we're not doing functional tests, but just because we're creating metrics, but they will add to visibility, right? So if I want to create visibility, I have to show something. So this is a quite popular setup to start with. Next thing with these, the people are becoming efficient about their peer reviews. So now we have metrics and code coverage and stuff like that doing all the hard work. So now we don't have to waste developer time in peer reviews trying to figure out if classes are spelled with capital letters or whatever. They can actually do real, genuine, quality oriented peer reviews. And we start automate the functional test. That's also what we see. We start automate the deployment so that the functional can be run as part of the sequence, because we want the deployment to be automated so the test can run. And if you are in an embedded software environment, this is typically also at this point where people start testing in target rather than simulators or emulators. And then if you dare it, you could start automating your acceptance test. For most people, this is actually not very relevant. One of the things that are true about all the things that we do in a pipeline is that we're trying to verify the code. But there is a difference to automation, automated acceptance test, because at that point you will be trying to validate the code, which is basically oh, I don't know if you lost the screen. I did. I'm trying again here. Sorry. Okay, so there's a difference between verification and validation, and most of the things that we do in the pipeline are actually verification steps. Validation is different, and you should potentially not try to automate that. In software configuration management, people start using branches, and they start using it kind of as release branches. So whenever I have a release for a customer, I put it on that branch. Later, it's called early branching because it refers to the fact that I would create my branches proactively. When I know that I need a version 1.2 of my product, I will create that branch and start delivering to it. The concept of late branching basically means that I have a stream-oriented approach to my branching strategy. So I have trunk, or I have master, whatever I have, and that's basically my going forward strategy. Branches are then used for isolation, and merges are quite common because people get isolated on branches and merge deliver into the master branch daily. So that's a fairly more advanced use of version control systems, and quite popular in distributed version control systems such as Git and Material. The next thing we see is that all commits become tied to tasks, so there will be a one-to-one relationship between any commit and a task in the change management system, whatever that might be. This is important because that's allowing us later in the process to create traceability and audit trails about what happened. So it's a very important process when trying to document what has been, which of the requirements have actually already been implemented. We also see at this point that if people are in distributed version control system, they are thorough when they commit in the version control system, make sure that their commits looks good. So if I want a colleague to review it, I do not have a fix for a particular case in my case management system that might spawn several commits. I will squash it into just one before I deliver it to my colleagues. The next one we see is a biggie, pre-tested commits. That is actually the second most wanted feature in the Jenkins community. It's basically an approach where you try to look at your own code base as if it was an open source environment, saying that I can see the code, I can alter it, but I do not have access actually to commit it into the core unless I'm one of the few core committers. So you take the automation platform, which could be Jenkins, and you replace that benevolent dictator that you would have in an open source environment, and you replace it with a willing serve. And then you have this automation platform actually looking at not if you commit into the integration branch, but now it's looking at if you flag that you want something in. And then the automation platform will see that and check out the branch where it's supposed to end, the integration branch, and then merge your branch in. If that is going well, if you don't have any merge conflict, it will continue and deliver that workspace to the build process or test process or whatever you want to do. And in the end, if the test is successful, that particular job will then commit your changes and say that went well. But if you fail, it will simply just roll it back. So this way you can guarantee for sure that the integration branch is kept pristine. You can lock it down. No developer will have access to the integration branch, whether you're in Subversion or Git or whatever you're using. It's simply not available. You can flag that you want in, and if you're in, the only way in is actually to do the right thing. Give it a ride through the pipeline. If you're done, then you're let in. This is a quite popular setup, but this is also where it's actually it's the no going back step. If you do this, there is no fast track, right? Then there's genuinely no fast track anymore. If you have set up commits that are tied to tasks, and you have create all these traces between your tests and your test results and so forth, then you can automatically generate your release notes at this point, which is also quite popular because actually generating release notes in most companies, that is a pain. That is something that takes sometimes days to generate release notes. And the information that you use for this is basically embedded in your systems. So if you could just trace it and make these tools integrate, then you could have a release note for free. In the visibility layer, you have basically that things should be notified to the people who committed the stuff in the early stages, and then you start on with showing more and more information, creating trend reports that you can actually use to monitor how you progress. You have monitors potentially hanging around your company that are actually showing this progress, and if you're really courageous, you can share this information with your customers so that they can actually see how your code is going. We see a lot of companies actually doing that when they have got their process in order. Then it's like bragging, isn't it? You can brag about your code. Look at me! I get a task in, and I get a requirement, and I just deliver it, and basically it runs through my pipeline, and you can see it when it's done. So that was it. I hope that you have any questions. You are more than welcome to ask them either at this session at the end or directly to us. We love to discuss these things.
Great, thanks, Lars.
I want to go through yeah.
Okay.
Helen, you said something?
I just said thank you.
Okay, thank you. Well, I have a few stories that I want to go through you. Basically, some of the stories that we used to pick up these observations. So these are real life stories that we went through with some of our customers and clients that added to what we would call best practices. The first one I want to take you through is what we call the token lamp situation. It was a medical company in Denmark. They produced a medical device. It was in FDA regulatory rule set that it should be compliant with. So they obviously had some kind of verification before commit. they actually produced a script which they named "May We Deliver," and each developer was supposed to run this script before he released it. So he would, when he would integrate, he would run the script, maybe deliver. That was kind of a Boolean function. If it was true, you could deliver, otherwise you weren't done yet. And it was kind of a drilled down version of whatever the nightly build was doing. The thing is that this script ran for like 25 minutes, so it would take a long time actually for a person to integrate something. And so every time a developer should integrate, he would claim that he would have a lock on the integration branch. He wouldn't be able to set that in the version control system, but it would be kind of a virtual lock. His colleagues should know that he is currently the one who is integrating, so nobody else should try to integrate, because that would ruin his test. So they came up with this token lamp here, which is actually a battery-driven rotating lamp that they would have in their office environment, and whoever had this lamp would be the one integrating. So if I wanted to integrate something, I would rise up and I would look at who has the lamp, and I would find it, and I would go to and ask that developer, saying, "Can I have the lamp?" And he would say, "Hell no, I'm not done." And then I would just, put a Post-it note on top of the lamp saying, "Okay, then I'm next in line. So when you're done, it's supposed to go to me." And he would sit there holding on to the lamp, and later another developer would come and say, "Can I have the lamp?" And he would say, "Hell no." And then he would put a Post-it note on top of mine. So basically this rotating lamp would have tons of Post-it notes sitting on top, basically just claiming that people would like to be able to integrate into the version control system in order to ship something. And this was integration hell. So we were introduced to this problem, and the customer asked us, "Can you help us implement the lamp?" And what they meant was, could we implement some kind of integration that would run automatically? And it was actually the first time that we set up a Jenkins environment running all the integrations that was needed. And we developed, they were using ClearCase. So for them, this particular customer, we developed the ClearCase UCM plugin for Jenkins. And they would then use this plugin. This plugin has this feature. So if you're using this plugin, you can basically just turn the pre-tested integration feature on and have it for free. So, so that was their setup. This is a picture of a national test stand with another customer of ours, which is basically, they're producing pumps, circulation pumps. And in the center of this picture, you have a few pumps actually going from one barrel to another. So they had an actual real test that would move 200 liters of water from one barrel to another. And then it would heat it up to 80 degrees Celsius and move it once again. And then it would run for half an hour, running dry run, just to make sure that the pump doesn't break if we try to run it without actually moving any water. This is a very important test for them. So this is the final test. The thing is that this setup that you have here at the picture, it's worth more than 2 million Danish kroners. And it's located in a basement, which is like 2 kilometers off-site where the developers are. And the way that you run this is actually that you go into this basement in the room, and then you are supposed to put whatever you want to run through a USB port into the computer at the table, which will then automatically flash the pump with this software, and then you have to run it. And this test will run for like 3 hours or something like that. And in that time, you're basically just supposed to sit there and monitor that everything goes wrong or right. So we were asked if we could somehow automate this, and actually it wasn't quite a big task because they already had the test software running on that computer. So basically what we did was that we hooked it up to the Jenkins environment that they already had and made that particular computer a slave to Jenkins, and then that would make that chair for sale because nobody actually needed to get in there. Today they can utilize this test setup 3 times per day, and it's all automated. It's late in the pipeline, so they're not running it, but then the software has quite a substantial quality to it. But it is actually running 3 or 4 times per day now. Fighting software entropy is, or technical debt is also a very important thing that you can achieve with continuous delivery. As I mentioned before, it's quite popular to start just producing tons of metrics about your code. And when you do that, it can be quite overwhelming. For instance, if you have no static code analysis and you turn it on a code base where you never did static code analysis, you would potentially see a lot of issues. And you would say, oh, this is way too much, I cannot handle that. So what we would do is that we would simply say that the acceptance criteria for one test is that it has the same or a better quality measure than the previous build. So you're basically forcing all your quality measures to go up if you're testing, or go down if you're looking at issues. But that becomes your definition of done, right? So if you have a unit test and you have code coverage, which is like 40%, and then you have added a new code, but you didn't add any unit test, then that would automatically bring your code coverage down a bit, because you have more code, less coverage. So now it goes to 38%, and that would fail the build, because the previous build that I had would produce 40% coverage, code coverage, and this one only has less. So for that purpose, the pipeline stops. So I would, as the developer, simply have to go in and add more unit tests. Actually, not necessarily to the code that I added, but more unit tests that would bring the code coverage higher than 40%, which it was previously, or the same. And people might cheat, right? And actually go and add unit tests to code that they didn't write themselves. But that's only doable in a fairly short amount of time. So at a certain point, people will start actually unit testing their own code. I have a few more stories, but I also, Helen, are we supposed to end in 3 minutes for questions, or are we supposed to end entirely in 3 minutes?
We can probably add on about 5 minutes for questions. We have about 3 questions at the moment. So if you could.
Okay, so I'll take another like 3 or 4 minutes and then answer the questions. Is that it?
Okay, great.
Okay, perfect. This is a story about a customer who actually had a lot of pain. They were also in a regulated environment, and every time they had to do a release, they would have to know exactly what are the requirements and tasks that we covered in this particular release, what is the bill of material, and so forth. They went in and added traces between all their commits and tasks, and all their tasks in the change management system. They would then be added a field called release node. So basically, a script was created that was able to run given two commits in a version control system. This script would then go through the version control system, gathering all the accumulated commits between those two, gathering all the files that were changed, creating a full bill of material, tracing all the commits back into the change management system, finding the relevant cases in there, and then looking for a field in the task that would say release node, and then capture that release node together with the caption of the release, and by those measures produce a PDF document that would be the release node. And at the same time, that would check whether or not there was actually any commits that did not trace to task, or if there was any tasks in their project that would not trace to any commits. So that would be wrapped up in a small plugin for Jenkins, and every time they run the pipeline, they would actually produce that PDF file to see if even that step was doable. This is also available actually as a free plugin for Jenkins at the moment. This is the last story I want to tell you about. It's this output is actually from a map file from a piece of embedded software. I don't know how many of you are actually working with embedded software, but you're supposed to look at these pictures and figure out if you're okay memory-wise in your device. And people, when they look at that, they actually have to interpret that and figure out whether or not they're okay. because if they don't have enough memory in their microcontroller or their RAM, then they won't be able to release. So basically, another plugin that was produced in order to produce metrics about this would take this information and then do all the hexadecimals numbers and turn them into decimal numbers and then show them in a graph. So this is basically the exact same information that you looked at before, but it's now presented to you in a small plugin that will do this every time you build. So on the x-axis, what you have the different builds as they go along. So this is also showing you the trend history. How is my memory being used? Yeah, that was it. I think I want to stop for questions.
Okay, so the first question that we've had is, what's the best place to start with continuous delivery? We've tried some agile techniques, but still very waterfall in our approach.
I would say that some of the best to set up some kind of automation platform, if that is not available, if you don't have neither Jenkins nor Urban Code, Bamboo, whatever, if being able to automate stuff is quite important. So having that that strategy in place is very important, because Agile is kind of the software pendant to Lean, and Lean is all about taking manual processes and automating them. Continuous delivery is very much about the same thing. You want to find out where things are, where time is going away from your efficiency, and then you want to automate that. So obviously an automation platform in the background is very important. But if you have that, then I would say produce metrics, test and quality assurance. That is the layer where you want to be, and do the most effort in the beginning. So you want to actually do unit testing, you want to do code coverage, you want to do functional testing, you want to do deployment, automated deployment. So the green area here is typically one that needs focus, and also the one that represents the most low-hanging fruits.
Great. Another question was, scrolling up, sorry, hang on a moment. How long will it take to implement continuous delivery?
It takes, well, this is actually one of the things that you would, that this model is supposed to help you with, because that's answered by a counter question. What is your ambition? If you want to score maximum in all areas, then that's probably going to take you a very long time. But again, perfection is the enemy of good, and if what you're looking for is good enough, then good enough is actually good enough by definition. It contains the word enough, right? So if you're content with whatever you have, and you find that implementing more would just be expensive, then that's where you're supposed to stop. But if you want to go all the way, then we have customers who have been working actively with implementing continuous delivery, and they are still improving, and they are not experts in all areas yet, and they are still improving, and they have been working on this for many years. So this is basically a different approach to software development. You start now, and then this is how you develop software from this point on.
Okay, and finally, what are the key things we need for success?
The key thing that you want is that you want to have a pipeline approach to verifying your software, and then you want that pipeline to be fast, right? So in the end, what matters most is that we can produce software with high level of quality fast, right? So basically, if we can produce software with high quality, but it takes us a very long time, we're still not good enough. And if we can release daily, but the quality is crap, then that's not good enough either. So the combination of actually having a quality level in your software that you can trust, and being able to do it fast, that is the two parameters that you should be looking at. do things faster, automate more, add more quality. So that's basically it.
Fabulous. Well, thanks very much, Lars. Thanks everyone for attending, and thank you for your questions. As I said at the start, we have recorded this, so we will send you slides and a link to the recording online. Thank you, Lars.
You're welcome.
Goodbye, everybody.